Let us start today meeting. Today we will speak about the wireless communications. In today's meeting, we will cover some of the points like how we can solve the problem of losing power in radio signals with distance traveled. This is regards the Wi-Fi signals, and also how we could prevent the interference between wireless signals being transmitted with different frequencies, and also how we can convert the data as a binary data to radio transmission to be transferred as Wi-Fi signal, and also how we can detect there is some error happen on the data and how we can correct these errors. Also, we will look about two different media of transmitting data technologies, which is the wireless Wi-Fi and Bluetooth. Also, we will speak about the secure of the systems, how we can make it secure on Wi-Fi access, accidentally or deliberate damage. So the first things we need to speak about is the attenuation, which is meaning the weakness of the signals as it travels away. So if the signal traveled in a long distance from the source, for sure it will lose its strength as far as its go. So attenuation means is the reduction of the amplitude of a signal. If you remember, the amplitude of the signal is the wave of the data between the top and the bottom of the signal, attenuation. So attenuation may appear to be a series disadvantages to wireless transmission. If you can see here in figure 1, the normal wave will be fixed between the radiation between the different ups and bottoms. It will be in a fixed range. But with times as it travel away, the wave will be in short, so it will reduce its strength. So with time, the length of the wave, it will become less. So in figure 2, we need to measure how the signals will be weakened or how much the signal will lose of its data as it's travel in distance. So in figure 2, this one show how the power spread after transmission. Regard the distance, if it's travel in distance 1 or distant 2 or distant 3. After traveling a particular distance, d1, the power in the wave is spread out over the area, indicated by curved square. So we will look always in a curved square. So if it's travel more, this means how much of its power it will lose. This one, 1 square. This one, 4 squares. This one, 9 square. So we will always see that the distance after twice the distance at D2, it's spread over the area 4 times the size. So it was before 1 square only, then it's become 4 squares. When it travels at distance 3, it will become 9 square. So to make it as a rule, the same receiving antenna at a distance D2, it will become 1/4 of the power, so of when it was at D1. And also at D3, it will become only 1/9 of its power. So we can measure how much the wave will lose out of its strength. This is called the inverse square law. The received power is proportional to 1/the distance power 2. So we will measure it in this way. So for example, if we have a fraction of the power would be received by the antenna at distance 4, if we need to measure how the strength of the signal when it's traveled to distance 4, it will be always the inverse square law, which will be 1/, the fourth distance to power 2. In this way, it will become 1 out of 16. There is additional attention introduced by the atmosphere, so we can expect the signals to be weak as the condition of the environment change, like what's the atmosphere around the wave, what is the weather conditions, and also what's topographical features of the natural terrain. Artificial objects around the signals like the buildings, the materials of the buildings, the traffics, and so on. So there are also other factors will contribute to the weakness of the signals. Measurements of such situation have shown that in urban environment, an inverse power law of 3 cube or 4 is a good representation. So for an inverse cube model, the received power would be proportional to 1 over d3. And for an inverse fourth power, 1 over distance 4. So d4 is the distance multiply of d4. Okay. More information. Can there advantages of the attenuation? We can consider it for a wireless communication and how it can be advantages. Yes, there are some advantage for attenuation because this means the signal when it travel a specific distance, their devices operating on the same frequency band will not interfere with each other because it's a travel in a specific frequency, and it's a frequency. This means we can reuse it again. For example, in mobile telephony, this feature is exploited by dividing the area of service into cells. This is the origin of the term cellular telephony because in cellular network we have a lot of communication around it, and each communication will be traveled in a specific frequency range. This means we'll know exactly to which level of signals this must be traveled. Cells are clusters together to enable frequency reuse. So in attenuation, if it's getting less in its strength, this means we can use again its frequency. Cells in a highly populated area, such as town center, are smaller to allow for a larger number of users for a given area. This means here we have more cells than in the town boundaries, because we need to serve more people here, and we need to make sure that is more frequency, different frequencies to allow the signals to travel in. Here, these frequencies can be reused after a sufficient distance to avoid interference, the positive features of attenuation. So here, if you can see, we have a center for each cell, and there are 6 cells around it, each one with different frequency range. Here is a 12 cells clustered, and this is the town boundaries. So if you can see here, it has more cells in the center of the city. Figure 4 shows transmitters at a particular frequencies that are separated by 2 cells using different frequencies. So at the center we have frequency 1 travel, then around each frequency 1 from F2 to F6 around each one. We have the figure shows for adjacent 7 cells a cluster. Each central cell is surrounded by 6 adjacent 1. And each cell has a base station operating on a particular frequency labeled F1 to F6. This allows to be travel different signals at the same time. Now we will discuss how to convert a binary bit stream into something that can be transmitted as radio signal. In order to represent the analog signal sufficiently, we need to transfer the binary numbers into a signal. So the signals has to meet 2 conditions. First, the signal must be sampled sufficiently frequently in order to represent all its sufficient fluctuation, and this is, as you remember from the other from other meetings, called sampling. So we need to take small intervals between time to sample the signals. The samples must be coded then using a sufficient, accurate, and precise number for each sample value. This will allow the signals to be accurate and not lost a lot of information. And this is called the quantization. Here in figure 5, you will see a segment of an audio signal. The horizontal axis represents the time, and the amplitude is represented by the vertical axis. So the signal in figure 5 is sampled sufficiently frequently to fully represent the original. Imagine that receiving the sample value and simply joining the dots smoothly. So imagine you got the values of the dots and you just need to connect them together to represent the original wave. This means you need to take the data in short times to represent the whole data and don't lose too much of its important information. Turning to quantization, which is in figure 7, the left half here of the figure shows the quantization intervals of 0.25 units. So we can imagine that we have some data lost between these intervals, whereas the right half, short times is taken between each intervals and the others, and this means the quantization here is giving and representing the data more accurate. So we will have lost of will have less of lost data. Now we will speak about the Wi-Fi and Bluetooth technologies, which are the two technologies to transmit the data wirelessly. These systems typically use low power transmission bands over distance. This means the data can be traveled between 1 meter and 100 meter or so. So what is the difference between the Wi-Fi and Bluetooth? Wi-Fi, we can connect the station there or the final ends in Wi-Fi either as ad hoc or as infrastructure mode. And Bluetooth, we will connect the individual station using one or more beaconets. So these two technologies will be discussed in more details. Wi-Fi is a name given to wireless local area networking. So WLAN is the wireless LAN technology used to cover a building or a small area wirelessly to enable transmitting the data over it. It's used the IEEE 802.11 standards. Wi-Fi enables devices like computers, mobiles, printers, any devices that has the ability to connect wirelessly to be access the networks together to form a local area network, LAN. So this way it can transmit the data between them. They can communicate with each other wirelessly. Wi-Fi networks are also used to enable mobile devices such as laptop computers and mobile phones to connect to the internet. This application of Wi-Fi is now common in public places, as we can find the Wi-Fi network available even on the street, airport, cafe, with a range of up to about 100 meters. So we can connect with any Wi-Fi network wirelessly. Long distance system also available for Wi-Fi. They are operating over several kilometers by using strengther of the network. So in wireless LAN, nodes, which is the end station of the network, it will become either the laptops or phones or routers or switch or anything any device can be connected wirelessly. They are usually referred to as stations, so we call them station. Acknowledgement is the fact that each communicating device acts as radio station, so this means it can receive and send information. It has a transmitters and a receiver because it can send and receive information. In each station of these nodes, the connection to the network is provided by a wireless network interface card. So it has to have some devices. It's called network interface card. The Wi-Fi network can be configured in one of two different modes. How we can configure the Wi-Fi network? We have two models, either as ad hoc model or as infrastructure mode. You will see the difference between them. If we are in ad hoc modes, we don't need a middle device to connect the devices together through it. Each device can communicate immediately with the other devices on the network. So this is the basic idea of ad hoc mode, as any device connect with any other device wirelessly without the need for a middle devices in range. In ad hoc mode, stations communicate with each other directly without the need for any intermediary or central control. This means even if you don't have a Wi-Fi network installed, but you have a Wi-Fi devices, they can connect with each other and send the data between them. Wi-Fi device come within a range of another. A direct communication channel can be set up between them. Imagine of this like if you connect your phones with as Wi-Fi device with your smart TV, which has the Wi-Fi signals. Then you can stream your screen of the phone to your TV. Here in figure 8 shows an example of the geographical layout of a network in ad hoc mode. The dark circle represents the Wi-Fi station, TV, laptops, printers, phones, and the concentric circle around them represent the wavefront of the radio wave. So this is the range that the signals can be traveled in this Wi-Fi setting ad hoc. Assuming each station is a range of all the others, all communication pairs are possibly as a fully interconnected mesh. Here, the infrastructure mode, we need some connecting devices in the middle. So all the devices are connected to the central device, which called the access point, AB, and any connection between the devices, it must be done through this access point. So the station and infrastructure mode communicate with each other via a wireless access point. Usually we have some router that also act as connector between a wired network. So we can also have with this access point another wireless devices that don't have the ability to connect wirelessly, and it will enable it to transfer data with the Wi-Fi devices. The access point is effectively a base station that controls the communication between the other stations, and each station exchange information only with the access point. So it cannot communicate with each other directly, but they need the access point to share the data between them. Access points form part of a wired network infrastructure and are not mobile. Infrastructure mode Wi-Fi network are used in public space such as cafes, libraries, and airports to enable mobile users to connect to the internet. They are also used in offices and homes to provide network connectivity without the need for expensive cabling to be installed, because you need only to connect wirelessly. You need to connect the wired devices only, but the other devices has the Wi-Fi technology. You will connect wirelessly, so you will have less and more wire to be installed in your network. For example, in an office setting, single Wi-Fi access point in a meeting room can provide a network connection for all participants in a meeting, whereas a single wired connection can be used easily by one person. So this is also advantages of the infrastructure model. Attenuation and interference. How we can solve the problem of losing the data in Wi-Fi connection. Lower signal strength results in a lower data rates because the lower strength signal is more sensitive to interference. With signal attenuation, the effective data rate reduces with distance from the access point, or in the case of ad hoc network, with distance from other stations. So for sure it will lose the strength as it's traveled away. The other contribution to the weakness of the signal is the physical barriers like the partitions, like the walls, and further reduce the maximum rate possible at given distance from the access point. So this table will show us the typical effect of physical barriers within a building. So if we have the location of the signals, how the obstacle between station and Wi-Fi access point can be, what is the type of the barrier between the Wi-Fi access point and the other connected devices, what will be the strength of the signal, and what will be the how many data will be transferred in this case. If we are in the second floor lobby and there are several thin partitions, walls, several doors, the signal will be very good and the data rate will be transferred at 9.8 megabytes per second. If we are in the stairwell and there are several thin partition wall and there is also concrete wall, several doors, the signal will be good, fair. The signal rate will be 6.8 megabytes per second. If we are on the left, this means there are several thin partitions, wall, concrete wall, several doors, metal lifts, door and wall. The signal will be very low and the transmission of the data will be 3.3 megabytes per second. Bluetooth technology. Bluetooth also used the standard of the IEEE 8.2.15 family. It also serves a small range of wireless devices, usually from 1 meter to 100 meter or so. Why they invent the Bluetooth technologies? Because they try to eliminate the need of the connected wires devices, especially in local places or local devices, like if you need to connect the keyboard, the monitor, the printers, the PDA, the phones and headset. They don't need to use the wire. So this was the need for the Bluetooth technology. Although there was the infrared technology, if you remember, the IR technology already was invented that time, but it should be for the infrared technology that the two devices, they must be line of sight positioning. So they has to be in front of each other. So it is not that sufficient if you need to connect wirelessly. This make the IR usefulness as we need to always to place the two devices in front of each other. And because Bluetooth use radio waves, this allows the devices, the Bluetooth devices, to communicate with each other without a line of sight. So they don't need to be in front of each other. We can transmit data over Bluetooth between two different rooms or two different houses, so they don't need to be in the same place. When switched on, a Bluetooth device locates others by transmitting a message that welcome I have a Bluetooth, I can receive information from the neighborhoods. So any two Bluetooth enabled devices, they can form an ad hoc connections. They can connect directly with each other and establish a personal area network between them. With a small number of other devices, each being identified by its MAC address. So each one will have an address in this personal area network, and then they will transfer data between them. Such a small network is called beaconnet, and in figure 10, this is the drawing of this beaconnet. In beaconnet, we will have a master device, which is in the middle, and it will be sending the message to the other devices, telling them, hello, I have a Bluetooth, I have a message to you. If you want to receive it, enable your Bluetooth devices or Bluetooth connection. So this one will act as master, whereas the other nodes will act as slaves. They will respond to commands from the master. The master here will control all aspects of the communication within the beaconnet, designating dedicated time slots when each slave can communicate. So it will master also the time of connection between the slaves and the master. This will prevent the slaves from sending the data simultaneously and is another way of organizing access control and avoiding collisions or contention between slaves for access to the master. Error correction. So how we can make sure that the message is sent properly without any mistakes. All transmitted data signals suffer from occasional error. For example, a 1 will become 0 or the opposite. The 0 will be received as 1. There are many methods used to detect any errors, such automatic repeat request, which is ARQ protocol, and also forward error correction, FEC code, and also the parity checks. Automatic repeat request, ARQ protocol, the sender waits for an acknowledgement from the receiver. So if I send you an information, I will wait for acknowledgement from you that you received the message from me. If the acknowledgement didn't receive, this means there is some error happening while transferring the data, and I will send you the message again. Wi-Fi network use this protocol. Here, we will speak about the error correction, how we can correct the error mistakes. We will have forward error correction, FEC code. This will be done by adding one more bit to represent the total ones as even or the total ones as odd based on the rule of the error correction. Is it even or odd? So another method might be for the speaker to repeat everything. Sorry, here the forward error correction. We will repeat the message 2 times. That one is different. That one is the even correction. This is called the forward error correction. So this will repeat the message more than once. In this case, if he saw one of the digits is different from the others, it will know which digit is the error, and it will match it with the more frequent data. So the listener will compare what the speaker said in each repetition and picks a version that seems most correct. Repeating message several times increase the bit rates required for transmission. For example, if I have the original message is 1001101, then the repetition of the data, let us say 3 times, it will repeat the first one 3 times, then the 0 3 times, then the other 0 3 times, then the 1 3 times, then the other 1 3 times, then the other 1 3 times, then the 0 3 times, then 1 3 times. So the original message, it will be 111, representing the first one, then 0, 0, 0 representing the second 0, then 0, 0, 0 representing the third 0, then 1, 1, 1 representing the fourth one, and so on until the end of the data. But for example, we received this data 1, 1, 1, 1, 0, 0. So we have here a mistake. We have error in the data. We received 1, but in the repetition it's 0, 0. So for sure, the one here, it should be 0, and it will correct the data. Here it's all 0, then this means for sure the data is accurate. Here we have 1, 0, 1, then for sure as 1 is more than 0, this means the 0 here in the middle is wrong. It should be 1. And so on. So it can detect which error and in which bit, and then it will regenerate the message again as a correct data. Parity check. Parity check is the simplest idea in error control coding, which is formed the basis of a number of more advanced techniques. The principle of the parity check is that for a given block of bits, you will add one further bit. We will call it the parity bit, which is chosen to be either 1 or 0, as so to ensure that the total numbers of 1 in the block of the bits, including the parity bit, will be an even number or odd number. So if it's odd parity, it will be odd number. Any single error in the block will now make the parity of the block of bits odd, because an error changes either to 1 or 0. So what's the idea here? The receiver can therefore just count the numbers of 1 in the message. If it's odd, this means there is some mistake on the data. If it's even, this means the message is correct. We will see in the example. Systems usually operate with low error rates, meaning that the probability of there being more than one error in a block of bits is small. So a parity check is a good way of being reasonably confident that there are no errors. If we have a 7-bit ASCII code, after adding the check, we will have 8 bits for each data. So an even parity, this means the total number of 1 in the message, it should be even. Here we have 0, 1, 1, 0, 1, 0, 1, 1. The last bit of the message is called the parity check, and we will make sure by adding its value, this means the total numbers of 1, it should be even. So here we have 1, 1, 1, 1, 1, 2, 3, 4, 1. This is a valid even parity. Here we have 1, 2, 3. This means there is some error in this data. Here we have 1, 2, 3, 4, 5 ones in total. This means we have some error in this data. Here we have 1, 2, 3, 4, 5, 6 ones in this data. So this means, yes, it's even number, even total ones, even one numbers. So this means we have a valid message. In parity checks also, we can detect where is the error, and also we can correct it. So it is a useful technique to correct errors. So to make sure here, figure 3, in this figure, we have a simple example of one way this can be achieved using 7 and 5 message blocks. So we have here 7 bits as a message, and we have also 5 lines of the 5 rows of the message. So we will call it 7 multiple 5 message digits. We will add one more row representing the 8th row as the bit for checking. We will add either 1 or 0 in the last bit here in the message to represent the total even numbers of 1. So here, for example, in the first row, we have 1, 2, 3 ones in the message. So the last bit, it should be 1 to give even numbers of ones, so that by the end we will have 4. Here we have 1, 2, 3, so the last digit it should be 1 to make the totals of ones 4, even numbers. Here we have 1, 2, 3, 4, so the last digit it should be 0 as we already have even numbers of 1. Here we have 1, 2, 3, 4, so the last digit it should be 0 as we have even numbers of 1. 1, 2, so the last digit it should be 0 as 2 already and even numbers. And this it must be done also horizontally and vertically. So if we look vertically, we have 1, 2, 3, so the last digit it should be 1 to give an even numbers, and we carry on the same way. So the last digit, it will be either 1 or 0 to enable the even parity checks. For example, if we have a 7 multiple 5 block with even parity checks, as in above example, is received as. So we have even checks, even parity checks for the last digits. We need to discover where is the error in which bit. So the idea here, you will count the number of ones horizontally and vertically. If you found one row or one columns have odd numbers, total 1, this means the error it will be here. For example, here we have 1, 2, 3, 4, correct, even. 1, 2, 3, 4, the second row is correct. Here we have 1, 2, 3. So the third row have odd number, totals of 1, 3. This means for sure the error will be on the third row. Now we need to check the columns. The first column has 1, 2, 3, 4, no error. 1, 2 in the second one, no error. 1, 2 in the third, no error. 1, 2, 3 on the fourth. So for sure the mistakes will be on the third row and the fourth column. So here will be the mistakes. This bit needs to be 1. So we discover where is the error in which bit, then we can alter it to 1. Wireless network, now we will speak about the security. Wireless network transmit data over a medium that is shared by everyone. This means anyone that can connect a compatible receiver also able to spy or listen to the message as radio signals being sent. One commonly used security mechanism is to do an encryption of the message. The idea of encryption is to take the information you wish to protect called the plain text message. So we will send the message as a plain text and transform it into different form called the ciphertext, such that only the people who are supposed to receive the information will be able to receive it as a plain text. A transformation process for converting plain text to ciphertext is called encryption function, and the reverse process is called decryption. So it is encryption and decryption. Encryption is transferring the message of a plain text to a ciphertext, whereas decryption is the opposite way, transferring the ciphertext to a plain text. Encryption has the security benefit of confidentiality, integrity, and authentication. So we will look more about what does it mean confidentiality. That means if a message is encrypted using a particular key, this means only the parties who have the key can retransmit the message to its original. And the key will be between the sender and receiver only, and the message will be confident between them. So the confidentiality, the act of keeping a message confidential by encrypting and decrypting using a key. If the attacker can guess the key, then the message can be read by him, and this kind of attack is called a brute force attack. brute force attack, try every possible key until you happen on the right one. So it will try to guess what is the key between the receiver and the sender to listen to the message. This means a number of possible keys that can be used by an encrypting function is an important factor that affects its strength. If the number of possible keys is sufficiently large, completely random, and impossible to guess, this means the brute force attack become much more difficult. They will find it hard to guess the number. Integrity is the prevention of message from being modified without the receiver knowledge. So there is no change on the message, and the receiver will know exactly if someone has changed the original message. The encryption will prevent the message from being modified without the knowledge of the receiver. The only way for a man-in-the-middle attacker to modify a message is to decrypt it. So if they know how to decrypt it, this modification, and re-encrypt it again, but this is possibly only if the attacker knows the key. So if they know the key, they can change the original message. Any attempt to modify the encrypted text would cause the decryption process to produce a meaningless message, which would alert the receiver that someone had tried to tamper with transmission. So, man-in-the-middle attack means a malicious user securely interposes between sender and receiver, which modifies or deletes information. Authentication means the process of proving the identities of the sender and receiver. So to make sure from the identity of the receiver and the sender, they will exchange some of a predefined message that are encrypted using the key, knowing only to them. So this exchange called a security protocol. They exchange a message already agreed between them. We finished meeting 10 by today, and as we have meeting 12 very long, I don't want to join it with meeting 12. Meeting 12 is short. So we will have a break for 10 minutes, okay? And I will explain meeting 12 today. So next week we will have only meeting 12. They are not connected together, so it's fine if we precede meeting 12 on meeting 11. Okay, so take a break for 10 minutes. We'll come back here by 7:05. Okay, and we will carry on meeting 12. So we finish meeting 10 and we will carry on meeting 12. Okay. Take a break and come back here by 7:05. Thank you.